Huh? Is that coming, my voice? So voice is reaching? Yes, good. Because voice is most important thing. Here only one thing's work, that is a voice. If my voice is not reaching to you, so it's like I have to start playing Damsaras, right? Good morning. So today, which chapter we'll gonna study? So today we'll talk some chapters that is related, or we can say that is useful to the whole living beings, or we can say this earth is surviving, or we can say even a single coin of energy, even a single coin of energy present on this planet is due to that, So can you tell me, good morning? Good morning. So everyone had your breakfast, or still it's a pending? So I hope you had your breakfast. Okay, why? Achha, because photosynthesis is not completed, right? Photosynthesis is the only process that will give you what? That will give you food. Cats are running for rats. Okay, good. So today we'll start with some chapters like that is just opposite to the chapter which you had. Like you have studied which chapter? That is the respiration. The last chapter or previous chapter was what? So it's a respiration. So are you doing respiration or not? Are you doing respiration or not? So obviously we all doing respiration. Without respiration, no one can survive on this planet, or we can say not a single organism can be living without what? Without respiration. Yes, you have your exam. So firstly, we'll start with the topic. So the name of the topic is what is the name of the topic? Name of the topic is photosynthesis. Dhanarsita, like I'm good. How are you? Okay. So what is the name of the chapter? What is the name of the chapter? Photosynthesis. Are you doing this? Anil, good morning. So are you doing this process? Yes, I had my breakfast because I need to spend energy. So obviously I should have breakfast, because without breakfast, how to form the ATP? So ATP is only formed after what? After breakfast, or before breakfast. So obviously it's after breakfast. So how many of you are doing photosynthesis? How many of you are doing photosynthesis? So I don't think none of you are doing this photosynthesis. That's a correct answer. I'm getting on the screen one by one. That is a correct answer. You people are not doing photosynthesis. So you are not doing photosynthesis means, can we say that you are not able to cook your own food? You are not able to cook, or we can say synthesize your own food? Obviously, always and always you are dependent on some XYZ organism that is capable to cook the food. And you can cook dragon. That's a great. What type of food you are cooking? It's a raw food, or we can say it's a cooked one. So obviously we are getting raw food from the plants, and thereafter according to my convenience I am cooking the food. According to my convenience, okay, biryani. So in photosynthesis, let's talk something, some basic concept about the photosynthesis, how the photosynthesis is working. So firstly, I will try to draw one diagram. So let's say this is nothing but the plants. There's nothing but this is plant. Okay, so in this plant, there is a chlorophyll or many other things are there. And I think it's early in the morning, right? It's early in the morning. So sun rises in the east or it's a west. So obviously sun rises in the east. So here it's a sun rises, and sun is the only source of energy, or we can say it's a ultimate source of energy. It's a ultimate source of energy. And on this planet, who can utilize this energy? So on this planet, the plant only can utilize this energy. Plant is the only organism, or we can say it's a living part that can utilize this energy, that is a sunlight. So here just I am writing what is this? It's a sunlight, and obviously this is a plant, or we can say it's the outline of plant. I am just have drawn. I am not drawing each and every part. I am not each and every part. So after that, what will happen? With the help of this, can we say that this sunlight is having a packet of energy? This one is having a packet of energy. So you can count this packet of energy. So you can count this packet of energy, or we can say it's nothing but the photon. It's nothing but the photon. After that, how this plant is utilizing this? So in the plant, what it is having? So the plant is having, it's a pigment system. Plant is having a pigment system. So this pigment system will convert this light energy into what? So here we can say it's a light energy into what? That is an intermediate form of energy. That is an intermediate form of energy that we can call it as a chemical energy. So it's ATP. Directly it will convert into the ATP plus one more is there. So we can say, so these are the convertible form of energy. So what is that? ATP. Everyone knows about the ATP, I think. How many of you don't know about the ATP? So ATP you know, right? So ATP is nothing but the simplest form of energy, or we can say it's a coin of energy that we can spend every time, that we are spending every time. Let's say I am having what? I am having like a total 10 ATP in my pocket. 10 ATP in my pocket. So whenever I need this energy, so I will pick one coin of energy and try to digest it. So it's not with the ATP. So plant is also doing the same thing. Firstly, it will store the sunlight energy in which form? Sunlight energy in the form of ATP and NADPH plus H plus. This is also coin of energy. If you are considering this is 100 rupees, so you have to consider this as a 300 rupees. 300 rupees. Why? Because one NADPH plus H plus is equivalent to what? Equivalent to how many ATP? So that is equivalent to, it's a 3 ATP. So that's why I said if it is 100, then we can call this chemical compound equivalent to the ATP, means it's a 300. Okay, is that clear? So one is 100 and one is 300. So in this form, they will just store the energy. They will just store the energy. Thereafter, what to do? So I think the most important part is to convert the carbon dioxide present in the atmosphere. So this carbon dioxide is converted into what? Converted into the bigger form. So a smaller form converted into the bigger form. So this is anabolic or catabolic. So it's anabolic or catabolic. I hope I will get the answer. That is anabolic, because small molecules is converted into larger molecules, or we can say it's a huge molecules. That is known as anabolic. So in this case, what will happen? With the help of this energy, or we can say this is nothing but the chemical energy. What is the form of energy? It's a chemical, and that too is, so it's a chemical energy. And this chemical energy later on converted into what? Later on, with the help of this chemical energy, it will synthesize CO2 with the help of water. It will convert into what? It will convert into the organic compound. Plus the oxygen will be released. So what is this organic compound? So we can say it's a monosaccharide. What is that? Monosaccharide. Mono means one. Saccharide means sugar. That is simplest form of sugar. That is nothing but here. So we can say it's a monosaccharide. And this monosaccharide, we can say it's a glucose. Good morning. So is that clear? Is that clear how the things is happening in the plants? So firstly, what will happen? There is a huge amount of energy is there in the sunlight. This energy is converted into what? ATP and NADPH plus H plus. With the help of what? Means what is required? What is the most important thing? So I think most important thing is a pigment. Without pigment is it's not possible to convert into what? That is a chemical energy. Now, with the help of this energy, that is ATP and NADP plus H plus. With the help of this, it will convert the carbon dioxide that is present in the atmosphere. Now, this carbon dioxide is converted into what? Converted into the organic substance, but at the same time H2O is also required. So at the same time, what you are getting? It's nothing but the oxygen you are getting. So this oxygen, whenever I am inhaling, I will use it for which process? So I think the previous chapter, that is a respiration. So with the help of this oxygen, I will inhale this oxygen and will start respiration. And in respiration, what will happen? So with the help of this oxygen, organic compound, I will produce what? Carbon dioxide. And this carbon dioxide again utilized by what? Utilized by the plant. So plant will use this for photosynthesis. So can we say that with respect to gaseous exchange, photosynthesis and respiration, both are same process or opposite process? So can we say that both are totally opposite process? In photosynthesis, CO2 is required. In respiration, O2 is required. In photosynthesis, oxygen is released. Oxygen is released. In respiration, CO2 is released. In respiration, CO2 is released. So that is a main concept, or we can say it's a main funda. If you have understood properly the respiration, or we can say concept of respiration, just reverse most of the process, not all process, most of the process you can reverse to get this chapter, that is a photosynthesis. Okay, so is that clear? How the things is happening, where the things are happening? Okay, so now we'll try to do some small introductory part of photosynthesis. Okay, so in photosynthesis I will try to add few points, or we can say that is points related to photosynthesis. Photosynthesis. So first point I am writing is, it is catabolic reaction or anabolic reaction? It is catabolic reaction or anabolic reaction? So we can say it is anabolic reaction. My first point is, it is nothing but the anabolic reaction. Okay, now my next point is whether it requires energy or it releases energy. Whether it requires energy or it releases energy. Can you tell me? So sunlight is required or sunlight is released? So I think it requires energy. It requires energy. So it requires energy. That's why we can say thermally it is nothing but the endergonic process. Endergonic process, or we can say it's endothermic process, what you are studying. So it's an endergonic process, means energy is required. Energy is required. Now, what else we can add? So we can add one more point, that is, it is known as physico, or we can say physico-chemical process. It's not the physio-chemical process. So in this case, what is, Russell, what's doubt? So can we say that it is nothing but the physio, or we can say it is somehow, we can say physico. Now next one is chemical. So can we say it's a physio? Physio means, or we can say physico means what? What is physical in this? So physical is sunlight. Sunlight is physical. With the help of sunlight, it will convert into what? ATP and NADPH. Later on, again it will be converted into the glucose. So that's why I can say physico-chemical. Light is converted into what? Converted into the chemical energy. So this is another part we can add. So this is another part we can add. What is another part? So light energy converted into what? Converted into chemical energy. That's why we can call it as a what? We can call it as a physico-chemical reactions. Okay. How many of you know about the redox reaction? Redox reaction. Okay, good. So can we say that redox reaction means I'm just considering myself as a chemical substance. I'm just A chemical substance and you people are B chemical substance. You people are B chemical substance. Okay, so let's say I'm just donating my electron to you. Donating my electron to you. So oxidation occurs in my body, and whenever you receive this electron, what will happen? You will be reduced. So I am getting oxidized, you are getting reduced. So can we say that this simple electron, one is losing this electron and other one is gaining this electron. So whoever is losing the electron is oxidizing, and other one who is getting this electron, or we can say gaining this electron, is getting reduced. So oxidation and reduction combinedly we can call it as a redox reaction. Is that clear? So here we can say that this whole process is nothing but the redox. So next thing we can add is redox reaction, or the process is nothing but the redox process. Okay. But at the same time, if you are talking about the CO2, so CO2 is getting reduced or CO2 is getting oxidized. So here my answer is CO2 is getting reduced. So that's why photosynthesis is also known as a reductive process. Photosynthesis is also known as reductive process. But what is the respect? So with respect to CO2. So my next point is photosynthesis. Photosynthesis is reductive process, but you have to mention with respect to what? With respect to, that is a CO2, because CO2 is getting reduced. CO2 is getting reduced. That's why I'm just adding this point. Okay, is that clear? After that, what else we can discuss? So we can discuss this. We can discuss more points related to that. So firstly, we have started with what? Like photosynthesis, it's an anabolic reaction. Why? Because small things convert into the bigger things. Small things converted into the bigger things. That's why it is known as anabolic. It requires a huge amount of energy. An amount of energy is needed. That's why endergonic process. Next one is physicochemical, means light energy. I am taking this light energy as a physical and convert into what? Glucose and rest of the part. So we can say it's nothing but the chemical, physicochemical. Redox reaction, just now I have explained what is redox reaction. In this, two chemicals are there. One is reducing one is losing the electron, other one is gaining the electron. So this coupled process we can call it as a redox reaction. Next one is with respect to what? With respect to CO2, photosynthesis is known as what? It's a reductive process. It's nothing but the reductive process. Obviously you can get the PDF, but as compared to PDF, this is somehow good to understand. Now, next one is, if you are talking with respect means what? I'm just taking this as a reference. What? CO2 is taking as a reference, and I'm just talking about this CO2. Okay. Next one is, if you are talking about the chemical reactions, or we can say reactions, what type of reactions going on? So the first part is I need CO2. Thereafter, one more thing is required, that is the most important thing. And what else is required? The green color thing, that is nothing but the chlorophyll. Chlorophyll is also required. After this chlorophyll, If you don't get sunlight, again this process will not occur. So sunlight is also required. Sunlight is also required. After that, what else we can add? So we just convert this into the glucose. The important part is C6 H12 O6. Later on, just will balance the equation. After that, some H2O is also released, plus here we can say oxygen will also be there. Oxygen will also be there. So after that, here just will try to compensate what you need. What you need, it's a 6 carbon is required. 6 carbon is required. So it's a 6. Thereafter, if you are talking about the H2O, so how many H2O is required? Thereafter, we'll try to balance this. Now, here also 6O2 is there. 6O2 is there. So 6 means 6 into 2, that is a 12 is here. Plus 6 more is here. 18. Next one is 6 more is required. So it's a 24. So somehow the equation is balanced. But at the same time, two things are there. So what's that? In this case, let's say it's a carbon dioxide. In this carbon dioxide, hydrogen is added or hydrogen is deleted. Or we can say it's a loss of hydrogen from this carbon dioxide or gain of hydrogen from this carbon dioxide here. So can we say it's a gain of hydrogen by this carbon dioxide? So if it is a gaining, so we can say carbon dioxide is getting reduced or oxidized. So we can say it's a reduced. After that, this H2O is having hydrogen, but at the same time it will lose. So here it's a reduction or it's a reduced or oxidized. So this is getting oxidized, and combination of these two can be call it as a redox reaction. So reduction is also there, oxidation is also there. So this is known as redox reaction. So directly question will be asked, water is reduced or oxidized? Water is reduced or oxidized? Water is reduced or oxidized? Oxidized, correct answer. Carbon dioxide is reduced or oxidized? Carbon dioxide is reduced or oxidized? So obviously carbon dioxide is reduced. That is the correct answer I am getting from you people. So carbon dioxide is reduced. So one is oxidized and one is reduced. Okay. After that, we'll go to the next part. So what's the next part? Like this is the photosynthesis is a process. It's a process, and someone has firstly discovered it, or we can say firstly described this whole process. So we'll talk somehow about the scientific contribution, or we can say who has contributed what and up to what extent in the field of this photosynthesis. Again. So can we say that plant is the only gateway of entry of light energy to this planet? Or we can say plant is the common gateway to enter the sunlight energy on this planet, or we can say to this planet. So if plant is not there, what will happen? Can we survive? If plant is not there, can we survive? So obviously correct answer is no, we can't survive without this plant, because whatever the amount of energy we are taking to us is coming from where? Coming from the sunlight. But directly I can't convert the sunlight energy into my energy. So I need what? I need an intermediate part, that is a plant. So plant is an intermediate one that will convert the sunlight into the chemical energy which we are eating every day. So I will add one more point. I will add not point, it's a diagram I am adding. So how many of you love to have the mango? So I'm just drawing one mango. So in this case, what will happen? So from this all the organic compound, or we can say glucose is converted into what? Starch. Glucose is converted into starch. Yes, somehow it's as compared to this, somehow it's bigger because it's a good plant. Thereafter, this mango, who can eat this? Who will eat this mango? So obviously anyone can eat this mango. So let's say this will eat the mango. So once this organism will eat this mango, after that what will happen? So after that this in this body, which type of reaction will start? So I think respiration will start. And whenever the respiration will start, it requires what? It requires oxygen also. And at the same time, what will happen? This will release CO2, and CO2 again will be used by what? Used by plants. So obviously it's a kind of exchange of gases. What we are exchanging? We are exchanging the gases between the plants and us. At the same time, plant is also making food for us, which we are eating in the daily life. Okay, so is that clear? Yes, obviously it's a digestion, but at the same time in digestion also it is required. Now after that, this is the chemical reaction. Thereafter we'll go to the contribution, some contribution, or we can say it's a scientific contribution. Scientific contribution, or we can say who are the scientists put forward, or we can say given his views regarding what? Regarding this photosynthesis, because everyone is having its own views, like photosynthesis is working this way, other will say that photosynthesis will work in some other way. Obviously this topic will be there. So it's a scientific contribution, and the first scientist who has contributed is, the name of scientist is Moll. And he has done one type of experiment that is known as Moll's half-leaf experiment. Moll's half-leaf experiment. So in Moll's half-leaf experiment, what is his conclusion? So conclusion we'll talk later. But before that I am just taking a jar. So let's say this is nothing but one bottle. This is nothing but the one bottle, and this bottle is not fully filled, it's a half filled. I have just filled this bottle with what? I have just filled this bottle with the potassium hydroxide. With potassium hydroxide. Now there is a plant. There is a plant, and the leaf of this plant is, I just put this half part of this plant, I have inserted, or we can say put into the bottle, putting it to the bottle, and thereafter properly just airtight covered this, cover it with the cotton, or we can say it. So now I'm just covering. Thereafter it's nothing but the sunlight. It's a sunlight which is falling on this. So in both the part, it is falling. So after, and it's fine, you can dip it, but obviously just put half part exposed and half part is inside that. Half part is inside that. So can we say that there won't be any CO2 inside this bottle, because you have already put what? That is a potassium hydroxide. So potassium hydroxide will convert all the CO2, or we can say will catch all the CO2. Will catch all the CO2. So can we say that CO2 is absent here? CO2 is absent here. No doubt sunlight is falling on both the part. But after analyzing this leaf, or we can say leaf is going for what? That is the iodine test. Leaf is going for the iodine test. So let's say it's nothing but the iodine test. And this half part is inside the bottle. Half part is inside the bottle, and half part is nothing but exposed. Exposed, or we can say it's outside the bottle. So in this case, can you tell me which will give the positive iodine test? Which will give the positive? Yes, Nagamesh, yes, PDF is there. Don't worry, in the next class, mostly we'll try to. But this photosynthesis chapter, you will be confused with the PDF. Okay. So in this case, I'm saying exposed part, this will give what? Positive. This will give positive iodine test. So positive iodine test means what? Like glucose, or we can say related compounds, that is a starch is present. Starch is present. So where the starch is present? So can we say that in the exposed part the starch is synthesized? Means starch is synthesized. So starch is nothing but it comes from the glucose. And how the glucose is synthesized? So glucose is synthesized with the interaction with the sunlight. Sunlight, CO2 and rest of the part is required for the glucose and starch synthesis. So indirectly we can say that sunlight is present in both. Sunlight is present in both. Chlorophyll is also there. So everything is common. What is not common? Or we can say what is different? What is different? So the difference part is CO2. Difference part is CO2. So can we say that from this whole experiment, CO2 is required for photosynthesis. CO2 is required for photosynthesis. So in this case, I'm just writing what is the conclusion of moles. And this will give negative iodine test. So positive iodine test means what? Starch is present. Starch is present, and in other case starch is absent. Starch is absent. So starch is present, starch is absent. Means photosynthesis is not there, but in this case photosynthesis is there. In this case photosynthesis is absent. So this is how you can. So what is the conclusion? Conclusion from this experiment is CO2 is required for photosynthesis. So CO2 is required for photosynthesis. So this is the one contribution, or we can say one scientist was there. Okay. Next one is what else? Like one of the most funny experiment, or we can say scientist, that is a Joseph Priestley was there. Joseph Priestley was there. He said that means like this part is there. Conclusion is CO2 is required. This CO2 is required for photosynthesis. So one more scientist will come. That is known as Joseph Priestley, and his experiment setup is also looking different from rest of the scientists. And the name of the experiment is Bell. Name of just tell me. I think you have studied this part. So name of the experiment is Bell. It's a bell-shaped what? Bell-shaped jar was there. So it's nothing but the bell jar experiment. Good. So here it's a bell jar experiment. In this bell jar experiment, what are the experimental apparatus, or we can say equipments? So he has taken, that is a candle. Next one is one small plant, that is a mint plant he has taken. So he just set up many experiments. He just set up, you can say rat, mouse, or whatever. So firstly, I will go to what? I will go to. So we'll place one candle. And just I'm trying to lighting this candle. So this is the candle, right? After that, one more thing is required, that is a mouse or rat, whatever you can say. I'm not good at it, but still. So after that, what will happen? So till this point, it's okay. Like mouse is happy or it's sad? Mouse is happy or sad? So I think till this point, the mouse is happy. Mouse is happy because it will get the oxygen. It will get the oxygen for the respiration. Okay. So after that, the candle is also, once you light this candle, so the candle will keep on burning. So candle will keep on burning. So in this case, after some time, he has done one more thing. So what's that? So after some time, he just placed one jar over that. He just placed jar over that. So So after putting a jar over that, what will happen? So in this case, if you are putting the jar over that, so in this case, few gases exchange will occur. So in the mouse, what is happening? Respiration, and respiration will give you what? Respiration will give you the carbon dioxide, and at the same time, the burning candle also produces what? Carbon dioxide. So the level of carbon dioxide is what? The level of carbon dioxide will increase, and over the time what will happen? The O2 will be depleted. The O2 will be depleted, and wherever you are living, or we can say wherever you are surrounding, wherever you are living, or we can say wherever you are staying, in that condition it's like totally open. In that condition it's totally open. So open means oxygen as well as carbon dioxide. Its amount is not varying. Amount is constant. Or we can say the composition of air is restored after some time. Once you get the oxygen from the environment, what will happen? The plant will add the same amount of oxygen to that. Same amount of oxygen it will add. Okay. So after some time, what will happen? The mouse, or we can say the rat, so it will what? So now, Joseph Priestley also sad for this. Joseph Priestley was surprised why this is happening. And after putting this jar, what will happen, or we can say what is new, so that this candle is also extinguished, means again it's not burning, and the mouse is not surviving, or we can say mouse will die. So what is the difference between that? So he said that some differences might be there. So he had just started experimenting with the new experiment, or we can say new setup. In this new setup, what is there? One mint plant is there. Near to the mint plant, what is there? After that, here it's nearby one candle. So once you are lighting this candle, so the candle will be extinguished, or it will just keep on lighting, or we can say keep on burning. So in this case, this all setup is perfect. So in this case, if you still want to just cover it with what? So cover it with so in this jar and in that jar. Yes, rat is totally happy this time, or we can say rat is happy because what? Rat is having what type of dinner? It's a candlelight dinner, we can say, right? So in this case, so rat is properly surviving. Why? Because rat is producing what? CO2. And in this combustion reaction, this also produce what? CO2. And both the CO2 can be consumed by what? Both the CO2 can be consumed by the plants. And at the same time, the plant will give what? Plant will give oxygen, and with the help of this oxygen, So we can say this is a perfect type of setup for the survival. Perfect type of setup for the survival. In this case, everyone is happy, like it's a candle is also lighting, and the mouse is survived, and at the same time mouse is not scared of what? Darkness. Why? Because you have lighting the candle, you have lighting this candle. So all setup is totally okay for everyone. So in this case, what you have concluded? Yes, rat is happy and it is surviving, or we can say it's alive. So what you have concluded, like if you have gone through this experiment, or we can say setup of experiment. So what you have concluded? What we have? Means rat is happy, that I have concluded. Oxygen is essential. Yes, somehow we can say, but we are talking about the photosynthesis. Rat is, means we are talking about the photosynthesis, not respiration. So can we say that? Can we say that this photosynthesis will restore what? Photosynthesis will restore the air, or we can say the composition of air. Composition of air. So here we can say conclusion. What is the conclusion? Photosynthesis will restore the air composition. Restore the air composition, because it will produce the oxygen, and oxygen can be utilized by the candle as well as rat. Okay. So this is the one. After that, we'll move to the next one. One more scientist was there, but in that case, what is happening? What is happening? So one more scientist, name is somehow weird. So what is the name of the scientist? So it's Jan Ingenhousz. Jan Ingenhousz was the scientist name. So another name of the scientist, it was Sir, weird name. So he was also talking about this experiment. So the same experiment that is performed by what? The same experiment that was performed by the Priestley. He just carry forward the same reaction to the next level. And in this case, he just took one aquatic plants. In this case, he just took aquatic plants, and in the aquatic plants, what is happening? Like few bubbles are coming, and that bubble is near to what? That bubble is near to the greeny part, or we can say green part of the plants. Not everywhere. It's a green part of the plant which is responsible for photosynthesis. So here, let's say just I'm drawing few parts. Let's say it's aquatic plants. It's aquatic plant, and only a small part is green. Only a small part is green, or we can say this part is green. And the whole thing is, it's aquatic plant, so obviously it will be in the water. It will be in the where? That is a water. So in this case, so let's say this is water, and in this water, the bubbles will come out. The bubbles is coming out, but the bubble is not coming out from this. This is not coming from this. This is mainly coming from where? Mainly coming from the green part of the plants. Green part of the plants. And this bubble is having what? This bubble is having oxygen, and this is the green part. Green part, and at the same time, sunlight is also required. Sunlight is also required. So, so what is the conclusion of this part? What is the conclusion of this Ingenhousz? So, can we say that conclusion of this Ingenhousz is in the presence of sunlight? Only the green part of the plant, is photosynthesizing. Okay. So here its a conclusion is, what is the conclusion? What is conclusion? In the presence of sunlight, the green part of plant is photosynthesizing. Only green part, not other parts. So that's why. So Yuvraj, what's your doubt? Enclosed bell jar experiment, there is no sunlight, then how? Obviously, it's a transparent bell jar. It's a transparent bell jar. So syllabus will be up to this. That will come in the test, that is tomorrow. Everyone got the result. I think ICSE result is also released, right? I'm just waiting for some questions if it is coming from your side. How to attend the exam? You can attend the exam. Okay, the green part. Green part. Okay. CBSE it's not there, but ICSE it's released. So whoever is from ICSE board got the result. Yes, blue to back. It's a human. Positive iodine test means yes, blue. Okay, so bye-bye everyone. For now, we'll meet in the next class with the new topic. So till this, take care.